Alright, so here we have a problem that says determine whether the following series converges absolutely, conditionally, or diverges with justification. So for our first one, we have the summation from 0 to infinity, -1 to the nth over the square root of n plus 1. So here we have an alternating series. So the alternating series test states that Bn has to be greater than Bn plus 1, and also that the limit of when n goes to infinity Bn equals 0. So let's plug in some points here. So if we plug in 0, we're going to get 1 over the square root of 1, which is 1. If we plug in 1, you would get 1 square root 2. So here we can see that our Bn is greater than B1, so that's good. And we can also see that it's going to 0 as well. So it checks off this one. So to see if it's absolutely or conditionally converges, we have to take the absolute value of that. So the absolute value of that would be 1 over n plus 1. And this, whenever we're based off the p series, our p here is 1/2, and that is less than 1. So it diverges, which means that it's only conditionally convergent. So this is conditionally convergent. For our next one here, we have the summation of 1 to infinity sine n pi over n squared. So n sine pi is always going to be 0. So no matter what number we plug in, it's going to be 0. So let's try and plug in some points. So sine 1 pi over sine squared is 0. Sine 2 pi over 2 squared is 0. Sine 3 pi over 3 squared is 0. So this is going to converge to 0.